Welcome to an in-depth exploration of the top 5 custom loss functions in PyTorch. In this video, you'll learn how to implement advanced techniques to enhance model performance, tackle complex datasets, and improve accuracy. Did you know that the right loss function can make or break your PyTorch model's performance? Welcome to our channel, where today, we're diving into the world of custom loss functions. Whether you're dealing with imbalanced datasets, robust regression, or even training GANs, mastering these advanced techniques is essential. Stay tuned as we explore 5 cutting-edge loss functions that will transform how you approach machine learning models. Let's get started. In the world of machine learning, loss functions are the unsung heroes that guide our models to learn and improve. They are essential in training models by quantifying how well the model's predictions match the target outcomes. While standard loss functions are often sufficient, they may not always fit the bill for complex tasks. Enter custom loss functions, tailored solutions that address specific challenges in your dataset or task. By leveraging PyTorch's flexibility, you can design and implement loss functions that significantly enhance your model's performance and adaptability. In the following sections, we'll unravel this powerful toolset. First on our list is focal loss, a game changer for dealing with imbalanced datasets. When your dataset has a skewed class distribution, traditional loss functions can struggle, often causing the model to be biased towards the majority class. Focal loss addresses this by down-weighting the loss contribution from well-classified examples and focusing more on hard-to-classify cases. This function is particularly useful in scenarios like object detection, where some classes may be underrepresented. Implementing focal loss in PyTorch is straightforward, allowing you to seamlessly integrate it into your training loop and improve classification accuracy. Next, we delve into Huber loss, a robust loss function that combines the strengths of both L1 and L2 losses. In regression tasks, outliers can skew results significantly. Huber loss mitigates this by applying a quadratic loss for small errors and a linear loss for large errors, offering a smooth transition that is less sensitive to outliers. This makes it an excellent choice for datasets with noisy data. In PyTorch, Huber loss can be easily implemented, making your regression models more resilient and accurate. Join us as we explore how to apply this loss function effectively in your projects.
For tasks involving similarity learning, such as face verification or signature verification, contrastive loss is a powerful ally. This loss function aims to bring similar data points closer while pushing dissimilar ones apart, thus learning a feature space where similarity is meaningful. By focusing on pairs of samples, contrastive loss enables models to understand the intrinsic relationships within the data. In PyTorch, implementing contrastive loss involves creating custom datasets and leveraging pairwise training strategies. This approach is pivotal in applications where understanding similarities and differences is crucial. When it comes to ranking tasks, triplet margin loss is your go-to solution. This loss function leverages triplets consisting of an anchor, a positive, and a negative sample. The goal is to minimize the distance between the anchor and the positive while maximizing the distance between the anchor and the negative. This is particularly useful in applications like image retrieval or recommendation systems, where the relative similarity between items is more important than absolute values. Implementing triplet margin loss in PyTorch involves designing appropriate triplet sampling strategies and integrating them into your training routine, ensuring your model learns a meaningful ranking of data points.
Adversarial loss is at the heart of generative adversarial networks, GANs, a revolutionary approach to generating realistic data. GANs consist of 2 competing networks, a generator and a discriminator. The generator aims to produce data indistinguishable from real data, while the discriminator attempts to differentiate between real and generated data. Adversarial loss plays a critical role in balancing this dynamic, driving the generator to produce increasingly realistic outputs. In PyTorch, implementing adversarial loss involves setting up the GAN architecture and managing the intricate training loop, ensuring that both networks improve iteratively. This loss function is central to tasks requiring data synthesis and creativity. Implementing custom loss functions requires a strategic approach to ensure they meet the specific needs of your dataset and task. Start by understanding the unique challenges posed by your data, such as class imbalances or noise. Design your loss functions with clear objectives and test them on small samples to validate their effectiveness. It's crucial to monitor your model's performance consistently, ready to adjust parameters as needed. With PyTorch's flexible and intuitive framework, you can experiment with different loss designs, iterate rapidly, and fine-tune your models for optimal performance. These best practices will guide you in crafting robust and efficient loss functions tailored to your requirements. Selecting the right loss function involves a careful analysis of your specific machine learning task, as well as the characteristics of your model and dataset. Each loss function offers unique advantages and potential drawbacks. Understanding these is key to making informed decisions. Consider what you aim to achieve, whether it's handling imbalanced data, robust regression, or generating realistic data with GANs. Balance the complexity of implementation with the performance gains expected, and be mindful of any trade-offs involved. By aligning your choice of loss function with your project goals, you can ensure that your model is poised for success.
As we wrap up this exploration of custom loss functions, remember that the right loss function is pivotal to unlocking your model's full potential. From handling imbalanced data to mastering similarity learning and beyond, these advanced techniques empower you to tackle complex challenges with confidence. We encourage you to experiment with these ideas in PyTorch and share your experiences in the comments. Don't forget to subscribe for more insights into advanced machine learning topics. Thank you for watching, and happy coding!